At this point, you should be familiar a little bit with acceleration and what acceleration means. All right, so let's go through this document and kind of talk about what all this means. First off, the first pre-question says, think about what the slope of a linear curve means. And if you think about what the slope of a linear curve means, it basically means rise of a run. It's a slope with your rise being your vertical direction, your run being your horizontal. For a velocity versus time graph, a velocity versus time has velocity on the y-axis and time on the x-axis. So a rise of a run is a change in velocity over time. And hopefully you understand that with a constant slope on a velocity versus time graph, it's a constant change in velocity over time, which is what acceleration is, and that's the name of this lab. All right, so for each one of these, let's talk about what it means to have an increasing or decreasing line on a velocity versus time graph. So the first one right here, graph A, you see that there's a straight line that's increasing on a velocity versus time graph. So try to think about what that means. What does this increasing line mean? Now, with a line that is increasing, that means that you have an increasing velocity over time. Increasing velocity over time. So is that speeding up or slowing down? Think about it for a second. An increasing velocity over time, that means it's going to be speeding up. All right, so speeding up because we have a positive slope, and notice we have a positive velocity. Velocity in the acceleration, slope being the acceleration. Velocity and acceleration are in the same direction, so it's going to be speeding up. And how do I know it's a positive velocity? Because it's above the x-axis. How do I know it's a positive acceleration? Because the slope is positive. All right, down on graph B, you see that we have a velocity versus time graph that's sloped downward. Now think about what that means. What does that mean to have a downward slope for a velocity versus time? If you think about it for a second, remember the slope is the rise of a run. We have a downward slope with a run, so we have a decreasing velocity over time. Now, that slope represents the acceleration, and we know we have a negative acceleration, and then the velocity is positive because we're still above the x-axis. All right, so with a positive velocity and a negative acceleration, you're going to slow down. Another way to notice you're going to slow down on a graph, on a velocity versus time graph, is if this line approaches zero, which this x-axis represents zero velocity. When the velocity approaches zero, that means you're going to be slowing down. If the velocity is moving away from zero, like it is in graph A, it's going up and away, then it's going to be speeding up. All right, so let's go to graph C, and this one might be a little bit trickier, but I want you to think about it. I want you to consider. Now, realize we're actually starting below the x-axis, and we're ending above the x-axis. All right, so try to think about what does this line mean on a velocity versus time graph? So with this increasing line, we have a positive acceleration because we have a positive slope. Positive acceleration because of a positive slope. Now, the first portion right here at the beginning, it actually has a negative velocity with a positive slope. So negative velocity and a positive acceleration means that this object is actually going to be slowing down. Now, it's a little bit confusing because you're saying, well, with a positive acceleration, shouldn't you be speeding up? Well, it depends. What indicates whether something is speeding up or slowing down is not necessarily that the acceleration is positive, but that the velocity and the acceleration are in the same direction. So after this point right here at the end, we have a positive acceleration because the slope is still upward, and we have a positive velocity, so it's going to be speeding up. But before this point, when it crosses the x-axis, it's a negative velocity with a positive acceleration. Another way of looking at it again is that the line is approaching the x-axis, which means it's approaching zero. So this object would look like it's slowing down, slowing down, slowing down, and stopping. Now, realize we're in the negative direction. The velocity is negative, so we're slowing down while we're moving in the negative direction. And then afterwards, we're speeding up, but we're going in the positive direction. So if you want to think about something that does this, essentially what happens is this object will slow down, stop, and then start moving in the opposite direction and speed back up. Something that does this with a positive acceleration is something like a tennis ball or an object that you throw up into the air. When you throw an object up in the air, there's an acceleration downward, which means as it moves up, it'll slow down, and then it'll stop when it gets to the top. But it's still accelerating, so it starts speeding up when it comes back down. All right. So let's look at the lab a little bit. In each one of these parts, we're actually going to reproduce graph A, B, and C. All right. So this first part, you see that we have graph A. The cart is going to be moving down the ramp as it's moving away from the motion detector. Now, I want you to think about what that actually means. Think about what that means when you're talking about the slow or the cart moving away. What does that mean for the position versus time? All right, so if you think about your position versus time is going to actually increase. It's going to go away, but it's going to speed up, which means every second that passes by, it's going to gain more and more position per second. So it's getting faster and faster. So let me see if I can show this on this graph. Okay, so it's going to start out with some position, and then it's going to increase its position. But then the next second, it's going to be going a little bit faster. So it's not going to have the same slope. It's going to have a steeper slope. And then the next second, it's going to have a steeper slope. And then the next second, it's going to have a steeper slope because it's getting faster and faster. And every second that passes by, it's going to increase more every second. Now, what about the velocity versus time graph? Well, if we're moving to the right, then we're moving in the positive direction. So we're going to be above the x-axis. All right, so let me see if I can do this. All right, so we're going to increase our velocity. Then we're going to increase our velocity again. Now, down a ramp, you actually have the same acceleration the whole time. So that means our velocity versus time graph is going to have a constant slope the whole time. All right, let's talk about graph B. Graph B is going to be, as we're moving away, we have some velocity, but then we're going to be slowing down because we're going uphill. All right, so let's do the velocity versus time graph first. Velocity versus time graph should be a little bit easier. Velocity versus time, we start with a positive velocity, but then we're slowing down. We're getting closer and closer and closer to zero. And since we're on this ramp is going to cause a constant acceleration, constant negative acceleration. So positive direction, but we're slowing down as we do this. All right. So what does the position versus time graph look like? Well, we're going to be moving away. So the position is going to be increasing, but we're going to be slowing down until we eventually stop. So every second that passes by, we're going to be gaining less distance until the very end where we gain no distance at all. So let's see what this looks like. All right, so position versus time. Remember, the slope of a position versus time represents velocity. So we're moving really fast initially, so it's a steep slope. But then we get a little bit shallower slope because we're slowing down. And then we're slowing down a little bit more. And then we're slowing down a little bit more. And then slowing down until we stop and our position stops. All right, next graph. So now we're going to be moving in the negative direction. So we have a negative velocity. All right, so our negative velocity, we start down here, but we start with some velocity. And as we go up, we're going to slow down. So a negative velocity and slowing down means we're going to get closer to zero. So we get closer and closer and closer to zero until we get to the top and we stop, and then we start coming back down. Now, as we're coming back down, we're moving in the positive direction. And because we're moving in the positive direction, we're going to be above the x-axis. And then we're going to speed up as we come down. So that's what our position or our velocity versus time graph is going to look like. All right, so what about our position versus time? What is our position versus time graph going to look like? Well, we're moving in the negative direction. All right, so we're moving toward the motion detector. So we start at some position away, and then we start moving towards the motion detector, but we're moving pretty fast towards the motion detector. So it's a steep slope. But then our slope gets shallower because our speed is decreasing. We're getting slower and slower. And then eventually we stop, but then we start going back the other direction. We go in the positive direction. So we have a positive slope and more of a positive slope and more of a positive slope and more of a positive slope. So we start speeding up as we go back down. All right. So these are our three graphs. This is what we should expect to see when we do each one of these.